Well, let me give a brief introduction to Dr. Wang's profile and what he's going to talk about. سخنران سوم امروز ما آقای دکتر جیانبین وانگ هستند. دکتر جیانبین وانگ مسئول ارشد نوآوری مؤسسه پژوهشی شهرهای حساس باب در ملبورن استرالیا هستند و در دانشگاه موناش این شهر مشغول به کارند. در این مرکز تلاش شده که با همکاری پژوهشگران و حرفه‌مندان مرتبط با پیشینه‌های مختلف دانشی به این موضوع مسئله آب و طراحی با توجه به مسئله آب بپردازن. ایشان رویکردهای مثل زیرساخت‌های چند عملکردی شهری رو در مقیاس‌های مختلف با همراهی تخصص‌های مثل طراحی شهری، معماری منزل و طراحی صنعتی دنبال می‌کنند. در تعامل با بخش دولتی، صنعت و پژوهش دانشگاهی پروژه‌ای رو با موفقیت در استرالیا، چین، سنگاپور و سایر نقاط جهان به انجام رسوندن. امروز در ارائه امروزشون دکتر وانگ به ایده شهرهای حساس به آب با بکارگیری زیرساخت سبز شهری چند عملکردی در مواجهه با چالش‌های محیطی شهری امروزه می‌پردازن و آنها رو در قالب پروژه‌های طراحی شهری و معماری منزل در فضاهای باز شهری نشون میدن. بعد از معرفیشون به زبان انگلیسی ازشون خواهش میکنیم که ارائه خودشون رو انجام بدن. البته به دلیل اختلاف زمانی که استرالیا با ایران داره، ایشون چند ساعت پیش پرزنتیشنشون رو ضبط کردن و برای ما فرستادن. الان تقریبا فکر میکنم 2 صبح باشه اونجا و به حال دیگه پیش از این بهشون خواستیم زحمت ندیم. Our third speaker is Dr. Wang. Dr. Jianbin Wang is Chief Innovation Officer at Cooperative Research Center, CRC, for Water Sensitive Cities and Water Sensitive Cities Institute based in Melbourne, Australia, collaborating with researchers and practitioners from interdisciplinary and multi-sectoral backgrounds. Jianbin translates research into practice and provides a transformative response to emerging urban challenges. He promotes multifunctional infrastructure and applies circular economy approaches to deliver water-sensitive city visions at a range of spatial scales using urban design, landscape architecture, and industrial design as integrated platforms. Jianbin has worked extensively with governments, industry, and research institutions. He has implemented over 30 on-ground demonstration projects across Australia, China, Singapore, and other parts of the world. Jianbin will present a vision of future water-sensitive cities employing multifunctional green and gray hybrid infrastructure as a response to emerging urban challenges. These hybrid infrastructure are integrated by landscape architecture and urban design, seamlessly embedded into the urban fabric. In his presentation, Dr. Jianbin Wang will also share a range of on-ground implementation from buildings through open space to the whole city scale as a proof of concept processing towards realization of water-sensitive vision. Jianbin's presentation is pre-recorded for this webinar due to the time difference between Australia and us. I think it's around 2 a.m. now in Melbourne. There is another wonderful video, especially for landscape architects, I will play after Dr. Wang's presentation, and then we probably have a constructive question and answer as well.
Hello everyone. Salam. Hale Shoma Chatori. Greetings from my living room here in Melbourne, Australia. I'm sorry I couldn't join the webinar live due to the time difference, so my apologies for that. But I hope you enjoy my presentation. I look forward to interacting with you in the future. So today we're talking about cities. And every city needs infrastructure. But we're constantly facing the decisions we have to make every day that shall we continue to build single functional infrastructure, or shall we think about building multifunctional ones, therefore deliver multiple outcomes and therefore multiple benefits? If we bring that argument into the different types of urban challenges, what we find that a lot of them are actually caused and partially by the single dimensional thinkings. and decisions we made in the past. For example, people in the past trying to improve the drainage efficiency by concretizing a lot of the nature creeks in the city. And therefore, we are not only losing the biodiversity for the creek, but also because we're trying to drain the water too fast, therefore we caused floodings at the downstream communities. Right? So we're not solving problems, we're merely shifting the problems away into other places and potentially cause more problems. So, and that just applies not only to to flooding and drainage issues, but also applies to a range of water-related issues. For example, the water environmental pollution and drought water scarcity, as well as the urban heat island effects as part of the climate change. And they collectively form what we call weak problems, meaning that if you don't tackle those challenges in the holistic approach, you're very likely to have unintended consequences. Right? That's what we call weak problems. So fundamentally, what happens, people ask. And this is what we find from the research. That if you look at the hydrological cycle of the cities, before the city is urbanized, every 100 volume of rainfall, about 85% of that is returned to the air by evapotranspiration. And that is done by the plants, vegetation, trees, shrubs, all of them, basically as a pump to pump the water back into the air. And only 15% is retained on the land in the form of either a surface runoff or a seepage into the soil. But once you start to urbanize, you start to develop that land, and of course, in doing so, you cut all the trees. What happened then is that number reversed. So only 15% is returned to the air because we lost all the vegetation and trees as the pump. Instead, we have 85% of that water retained on the land surface, and primarily in the form of surface runoff and some seepage. And what happens when we try to urbanize that? We usually put stormwater pipes, right? And that causes two major issues. One is the water is drained too quickly to the downstream, and secondly, that water wash off the urban surface and bring a lot of the pollution, what we call diffuse pollution, into the downstream and therefore to the receiving environment. So one of the early applications for nature-based solutions is actually trying to tackle the diffuse stormwater runoff that runs from the urban surfaces. Right? For example, there's a lot of research back then in Australia about 30 years ago look at how do we use some planters, sort of the sunken vegetated space, trying to treat the stormwater to clean that off. Right? And there are two major type of nature-based solutions for stormwater quality improvement. The first one is called barrel retention system, which you see is on the top here. Basically, it is a vegetated, like a garden bed, but it's actually sunken, so stormwater can flow into it. And once it flows into it, there's a vertical filtration happening. The percolation through the soil particles and the soil profiles together have some reactions with the vegetation roots, and it will start to clean that water as the water moving down that soil profile. And then the clean water can either be discharged into the drainage or can be collected and used that for non-potable consumptions. Right? So that's called barrel retention system. The second system is called surface flow wetland. It basically uses the horizontal flows as the water flows through the plants, and the water and the particles and the pollutants start to interact with the biofilm that attach on the stems of those plants. Right. So you can see this diagram that the plants are actually rooted in the soil, but the stems become a home that you have a lot of biofilm, the bacteria to grow on the surfaces. And as water moving through horizontally through the densely planted plants, those biofilms start to take up a lot of pollutants. And the same process as a nature wetland, but in the constructive form, we'll be able to use the same hydrology but increase the efficiency so that we can use less space, less land take to achieve the same treatment performance. So those are the two types, fundamental types that we used as nature-based solutions for stormwater quality management. And then what happened is when you asked, once we treat that water and when that water become clean, why should we discharge that water to the downstream? Why not we should think about reuse that water? And then we look at a lot of research and look at the numbers, the water consumptions in the city. It actually makes sense to use that stormwater. I use Melbourne as an example. In 2013, the city of Melbourne consumed 374 gigaliters of drinking water. Well, at the same time, the city produced about 440 gigaliters of stormwater from the city surfaces, and then also produced 443 gigaliter wastewater from the city. So if you think about it, if we can use the stormwater and wastewater generated in the city, you add these two things up, it will far exceed the drinking water consumption. So we basically say, if technically speaking, if we can use the stormwater and wastewater well, we don't have to divert water from far away, from further upstream in other places through a long distance to supply the city. And we call this concept called city as a water supply catchment. So really trying to encourage people to think about what resources can we use within the city boundary before we start to think about diverting water from elsewhere. And of course, we say that we're not saying we try to drink stormwater or drink recycled wastewater. All that's saying is that stormwater and wastewater could be recycled to at least replace the non-potable water consumptions. For example, do we have to use drinking water to flush the toilet? The answer is no. So the principle of city as a water supply catchment is a really important strategy to deal with climate change, because the wastewater generated within the city is fairly constant, and the stormwater runoff that is primarily coming from the impervious fractions of the city surface, so that's less dependent on the moisture of the soil. And the other aspect or impact by climate change is, of course, urban heat. And if you look at this case, that is the in Melbourne, what we call a Black Saturday in 2009. In the photos on the top left show you it is massive disaster to the public transport because the heat actually deformed the railway tracks. But the impact is not only just on the public transport. It's more importantly is actually look at the public health. If you look at this diagram on the right, it's really looking at the impact of heat on the modality and the mobility of the peoples in the Melbourne. And the x-axis is the daily mean temperature, which is the maximum plus the minimum divided by 2, and the vertical axis is the people who die from those heat wave days and divided by the normal rates. And this is looking at a community that is about 64 years old. And if you look at this, you can see there's clearly a jump as soon as the temperature is about 28, 29, approach 30. Right, you see a big jump in terms of the number of people die in those days. So what we're saying is that if the water sensitive city approach or how we manage water can reduce the temperature by 1 or 2 degrees, we can potentially save a lot of lives. So that's how we approach the urban heat mitigations from a water perspective. How do we actually do that? And there are two principles that are coming down from our research. And the first one we say is we want to keep trees in the landscape. For example, we have done a lot of experiments to look at as the tree canopies and the shading cast by the trees, how that's impacting on the land surfaces. And if you look at the image on the top right, in a particular thermal images, you will see that the shading areas is much cooler than the asphalt that is in the road that is directly under the sun. Okay, and that is the difference could be up to 20 degrees, right? So really keep urban trees in the city landscape is a very important strategy to mitigate urban heat and reduce the land surface temperature. And the second principle, what we call it, is we want to keep water in the landscape. And if you look at this analysis, we basically look at the land surface temperature across a different land surface covers. Right? And you will find that during the day, the water surface have the lowest surface land surface temperature. Yeah. You can see on the image on the left here. And then the second locus is actually the irrigated grass. And that is quite surprising because we intuitively think that any green space will have a lower temperature than the concrete surfaces or asphalt or impervious surfaces. But it's actually not. The green space only can reduce the land surface temperature if they are well irrigated. Right? And that's what we call it the second principle. We want to keep water in the landscape, not just about water body in the landscape, but also we try to irrigate and increase moisture contents in those green spaces so we can bring the land surface temperature down to cool the city. So that was a crash course on some of the fundamentals that inform us how do we manage urban water in a holistic way. And it all leads to this point about building multifunctional hybrid infrastructures. Not only because we're trying to deal with multiple challenges, but also about we're trying to achieve land use efficiency. Okay, because different sectors, for example, water, energy, transport, education, you name it, they all competing for land in the limited space in the cities. Right? So multifunctional actually can promote the land use efficiency. Just as 20 years ago, and people trying to carry a MP3, a Walkman, a digital camera, a laptop, a notebook. But nowadays, everything just consolidates into one smartphone. And for the city, it's the same. So what is a multifunctional infrastructure? I start with a very simple example. Think about an urban tree. Right? The conventional one is trees planted in a tree pit next to the road. They are in a raised form, so the surface is actually higher than the road. And the trees are there primarily serves an amenity and landscape purpose. But if we change the way how do we design and implement trees on the streetscape, so that instead of raise them up, we actually sunken them down. And also try to break the curbs so that every time it runs off the road, the stormwater actually runs into the tree pit to irrigate the tree first before it goes through the drainage. And if we make this tree as a bioretention system, what happens is that the water will start to percolate down and through the tree soil profile interact with tree roots and the bacterial communities in those environments, clean that water, and the clean water then will go through drainage as a way to manage stormwater runoff quality. But what is smart about this is because the things that we see as a pollutants is actually viewed as a nutrients for the trees. So it's a great solution to trying to combine all the objects into this one updated street tree format. So if you look at this closely, if you think about, if you roll this out across the city, every tree is like that. And what happens then is that you have multiple benefits. First of all, you increase the growth rate because every time it rains, the tree get a drink. And then secondly, because the tree is well irrigated and that water carry a lot of the nutrients, nitrogen and phosphorus into the soil profile, the canopy actually is become, the roots healthier, therefore the canopies become healthy and they become larger than the normal street trees. And they also increase the lifespan of the trees. And then if you have the whole street as a very leafy environment, and that potentially will increase the housing price in that street. And of course, we'll have water quality benefit we just talked about. And most importantly, we have a larger canopies and therefore large shadings that will help to manage the microclimate, trying to cool the urban environment. And of course, if we create a lot of these little detention systems in the city, will also help to manage the frequent flow of flooding events. So those are a number of the key benefits associated with a multifunctional urban. And if you quantify those benefits into monetary terms, and using Melbourne as an example, and the 75,000 trees across the city of Melbourne will value at almost $800 million. And the second example I would like to give is these canals. For example, I briefly talk about the concretization of the nature creeks is old-time fashion, and then later on, a lot of people profession trying to restore the creek. And using this example in Australia, you can see that on the top left-hand corner is before restoration. And you can see it's a concretized and there's no ecological value and there's no water most of the time. So it's clearly a single functional infrastructure and mainly catered for drainage. And once we restored it, you can see what we have done is to create a meandering creek. At the same time, we create this pool of riffles that holds the water in the creek and progressively build an in-stream as well as a repairing ecosystems. At the same time, we actually maintain and preserve the drainage capacity of that canal and slowly trying to reestablish an ecosystem and bring that back to this creek. And you can see that there's a before and after image and give you a clear idea how a multifunctional infrastructure compares with a single functional infrastructure. So what I'm going to do next is to walk you through a number of implemented projects and spanning across the different spatial scales, all the way from building to open space to precinct and all the way to city scale, and trying to demonstrate how do we use different integrated platforms to implement those hybrid and nature-based solutions into the urban fabric. So I will categorize those examples based on different scenarios in terms of their the first one I'm going to talk about nature-based solution for buildings. All right. So this is a little laneway in the city of Melbourne, in the CBD area. And I'll give you this extreme example because people always ask whether nature-based solution can be applied in the very dense urban environment. For example, in Asia, right? And this give the answer. What happens? You can see the image in the middle is basically a small bell filter planted box. It's only half square meter large. That's connecting to this downpipe, which carry a portion of roof runoff right into this bell filter, into this planter box. And what happened is that because we understand the ratio of the trim area of nature-based solutions against the catchment areas, so there's a ratio of that, so that we can, by breaking down the catchment, we're actually breaking down the trim areas. Therefore, we can really make the trim size really small and therefore distribute it across the urban environment. Okay, so that shows you how powerful the nature-based solution is, because it's completely scalable and it can be applied in a very dense urban environment. And instead of just managing the roof runoff, its quality and quantity, but what it also does is that the vegetation we plant into the bell filters actually is a climber. They also help to climbing up and increase the to basically greening up the laneways, increase the livability of the city. And this is the net building in Melbourne, Docklands. And what you'll see here in the photo is actually a constructed wetland as part of the building landscape. Right. What happened is that this building have one siphonic drainage pipes, a down pipe coming all the way down into the sediment basin, which is starting point of this wetland, and then the water is moving horizontally from the screen into you through the wetland treatment, and then the clean water is harvested in the underground tanks. Then the water can be reused for park irrigation, for landscaping, and also the general cleansing about pavement. So that's the nature-based solution for buildings. And then we'll talk about nature-based solution for plaza and car parks. So here example is in one of the suburbs in Melbourne. We call it structured trees for car park. So I think everyone have this experience. In the hot summer, you really don't walk into a really hot car that is directly under the sun. You much prefer to park the car under the tree so that you have a tree shade. And why it doesn't happen all the time is because if you just plant a tree in a car park, the soil will actually become compact. Therefore, the roots won't grow into a larger healthy system. Therefore, you won't have the healthy large canopies. And that because of the traffic will carry a lot of weightings and therefore compact the soil. And one of the solutions is that maybe we can do a structured tree pit. What we mean by that is that instead of having the soil bear all the loadings, we actually use some structures. As you can see, it's a modular system. So the structure actually bury a lot of the vertical bearings from the traffic on the top. Therefore, if you fill all the voids with a good quality planting soil, and that soil will always remain well aerated because they're loose, and they will, if you combine that with stormwater harvesting and passive irrigation, it will also become well irrigated. Then you plant trees strategically into a few tree pits. Then that tree roots will become very healthy and grow very large, therefore support very big canopies. And that canopy is the shade you would like to see in the car parks. Next example is again in the city of Kunshan, our incubator city in China. And this one you see we actually build 3 constructed wetlands right into a civic plaza. You can see here. What happened is this wetlands have 2 operation modes. During the rain, a portion of that plaza runoff actually needs to run into those wetlands first for treatment before it goes into the creek. And during the dry weather events, that 3 wetlands is actually helping maintain the water quality of a huge ornamental pond, which you can see on the top right, to maintain water quality through a recirculation scheme. It's similar to a diabetes patient have that kind of circulation system going. And as you can see that because of this, that ornamental pool is no longer requiring a potable water, a drinking water to maintain it. Everything has been done by stormwater. In terms of landscape design, you can see that it is not a piece of engineering solution. It's actually well integrated with this civic plaza with the open space. And at the same time, we're trying to turn that into a little botanic garden where you can see each of the squares occupy one native aquatic species. And we also plant this swamp cypress to bring the vertical dimension of the treatment systems and trying to increase the landscape value. And also we make it walkway really wide so people can walk into it and have a closer interaction with those native vegetations. Next one, I'm going to increase the scale again. We'll talk about nature-based solution for small parks. This is one example in Melbourne. just next to the CBD area. So it's called a feasibility garden stormwater harvesting scheme. And what you see here is that the photo on the left, there's a bit of a wedge-shaped garden. It's actually a bow filter. So every time it rains, the water will be diverted from a huge stormwater pipe on the left into an underground tank, which you see a construction photo here, which is directly underneath this grass. And then the water will be pumping through this bow filter for treatment, and the clean water will be stored as an irrigation source for the park maintenance, for long irrigation, for trees, also for some landscape water features. Right. And you can see the way we designed it is well integrated with this open space. And the seating areas is especially designed as a cutoff, so people can see the actions underground and hear the sounds of water harvesting when the system is in operation. So that can show you, how small the system could be, and it can be well integrated with the existing. And by the way, that project will be the virtual reality show, which I'll be leading all of you into that platform tomorrow morning. Okay, next one I'm going to talk about nature-based solution for roads, which is the typical application environment facing day by day. So the first example I'm going to give you is the Kunshan Jianbin Road in China. So this is very classic because every road, most of the roads, they will have a because of the construction, the gradient of the road sometimes wrong. Therefore, they create some hotspot, flooding hotspot, what we see here. So the top left photo is give you a sense of before the construction. That's where a lot of ponding water happens every time it rains. So instead of regrading that road or building another drainage to take that water away, what we have done is actually let that ponding water run into the green buffer. And what happens is we break the curbs and build a rain garden right into that landscape buffer. And you can see now every time it rains, the water actually finds way into a rain garden and get treated before the water finds way into the drainage system. And at the same time, we plant a diversity of different plants, even including trees, and that become a much diversified and much rich landscape response compared to what was before just a grass. So that's one way to show how we retrofit our urban environment to accommodate nature-based solutions to solve some of the flooding issues. Second example is in the same city. This time around is a central median. The whole street is sunken in the middle, high on both sides. So every time it rains, the road runoff actually runs into the central median. You can see there's a lot of breaks in the curbs, so water can run into the system and get treated before the water goes into the drainage. For water quality improvement as well as flood detention. You can see you can have this well curated, manicured kind of garden type of response as part of the streetscapes. So instead of having a traditional raised garden bed, now everything has been sunken and it has a certain function. And this example is again central media, but it is now in Melbourne. So you can see it's quite different landscape response because of the cultural difference. But again, this road is in Limbo Estate. So again, the road is high on either side, but low in the middle. So water is running into this center median, and there's no curbs, so the curb is flush with the road surface. Right? So during the minor rain, the water will run into the center median and get treated by these vertical biofilters, and water then pick up by the downstream pipe and to harvest that water for irrigation. And in the larger events, the whole central median can become a drainage system. So it become flooded and carry that flood water downstream to increase the overall drainage capacity. But most importantly, you can see those trees has been planted in the intercentral median because it is passive irrigated, so the tree grow like crazy. Like compared to other as similar environment in other states, these trees grow much quicker and become much healthier. Therefore, it quickly establishes much better ecosystems within this neighborhood. Next one, I'm going to talk about nature-based solution for rural areas. It demonstrates the nature-based is not just for urban environment, but it also can apply for villages, for rural environment as well. The first one I'm going to show you is in the city of Kunshan, is what we call an organic farm. So you can see this photo. This farm is actually a self-contained system. So every time it rains, all the stormwater runoff from the agricultural services actually need to run into these linear water bodies in the middle, right? So there's no direct discharge from this agricultural land to the external environment. Right? So everything has been harvested, and then that water will be reused back to these different patties for irrigation. And the water top up is from the adjoining lake, as you can see on this photo. And because we have designed this as a well self-contained system, the operators of the farm actually progressively get organic certificate because there's a clear cutoff of the external pollution. Everything can be contained, well managed within its own footprint. The second project, village project, is in the same city. Right? And what you'll see here is an old clean factory used to produce a lot of bricks for the region. Right? And what we've done is we're working with the Kunshan authorities to restore this factory into an art exhibition gallery, and then build a number of boutique hotels. That is the to the right, which you can see here. And because it's adjoining to the lake, if that wastewater is treated and discharged, that will become quite a pollution loading into the lake. And what we have done is actually take that water from the wastewater treatment facilities and take that water right into this bottom left corner is a community garden. And that effluent from the wastewater treatment facilities is reused back to irrigate this garden. Right? So we call it water food nexus. And also, if you look at closely, the interface between the lake and the clean factory and the pavement, there's quite a wide wetland buffer, right? And that is well designed to try to capture all the runoff from the site and treat that water and buffer that water before it goes to the lake, trying to protect the lake, the precinct lake water environment. Next one is nature-based solution for multifunctional waterways, or water bodies, sorry. And this one is called a Hackers Estate, and it's in one of the suburbs in Melbourne. And what happened is that we should have done a huge retarding basins as part of open space for this huge estate, as you can see on the plan on the top right. And what we have done is you can see this photo itself is a sunken retarding basin. So when during extreme rainfall events, everything will be inundated and trying to reduce the stormwater discharge from the estate, therefore to protect the downstream. What I want to show you here is because we want to demonstrate different nature-based solutions can be applied together, and they actually can be stacked up if you like. For example, you can put the lake into a retarding basin. You can also put a wetland into the lake. Therefore, they almost become a Russia nesting doll system, if you know what I mean. They achieve a maximum land use efficiency because they are not mutually exclusive. Through a well-designed process, they all can be integrated. So they are sitting within each other. The second project I want to show you is the Kunshan Forest Park. Again, you see these huge water bodies. In the past, this water body, this lake, is actually isolated from the rest part of the city because they worry about the pollution from other parts. But because of that, this huge lake won't be able to contribute to the flood retarding for the city because they are disconnected. And what happened is, in this project, we managed to convince the government to say that you can actually open the whole park up and help to mitigate the regional flooding, because we can help you to build a constructed wetland system next to the lake, so that when the lake water is impacted by stormwater, you can actually start this recirculation scheme to manage water quality. And therefore you achieve many functions, right? You can achieve flood retarding function and as a huge service to the region. And secondly, you have this constructed wetland to maintain the water quality. But at the same time, a forest park can now become a wetland park as well. And then we build a very a detailed pedestrian movement system through the park, so that this piece of infrastructure, nature-based solution, no longer just for the water, but also for the general public. So bring people right into these spaces, so they understand how they function and how they benefit the city as a whole. Lastly, I will talk about nature-based for a multifunctional corridor. You can see the scale become larger and larger. And this one I will show you again is in our incubator city in Kunshan. It's a multifunctional road corridor. You can see on either side of the road there's a quite wide green buffer. And the buffer is not only just manage water quality, runoff or floods, but also been designed as a linear park system. Right? So it's no longer just a green buffer for people to move through, but it's also part of the destination for the people to enjoy. So those amenities is bring right to your doorstep to benefit those estates that's along the way. And second one, I will show you this multifunctional corridor in the Kunshan Ring Road project. And what we call this is a gray, green, and blue corridors. As you can see on the photo on the right, gray for transport, green for landscape, ecology, and blue for waterways. So how it operates, during the rain, all the road runoff from these elevated highways will discharge into the wetlands that is within this green corridor. And the water is treated before it discharges to the blue corridor, which is the canals on the right. And during extreme floods, that canal on the right can actually start rising up, start to engage part of the green corridors to increase its flood conveyance capacity. So the boundaries between the green and the blue will become blur. Right? So that's what we call a multifunctional corridor, because it serves a lot of functions and bring a lot of benefits to the community, especially during the dry days. Those green and blue buffers is no longer just idle. They're actually part of the slow movement networks for people to move across the city, but also as a very linear parklands to benefit adjoining communities. Okay, I would like to stop here and just to summarize that I provide a lot of build examples today, and the idea is to give you a lot of confidence that multifunctional infrastructure or nature-based solutions is no longer just a piece of ideas sitting in a laboratory or in the universities. It actually has been applied at multiple scales and across different cities, different countries in the world. Okay, so I would like just to give you the three key principles for practice that underpins the water-centric cities. The first one is the city as a water supply catchment. So really saying that we're trying to access the various source of water, not just about the water that we divert away further upstream from the city. We have to look within the city and to see what we can use in the first instance. And the second principle is a city providing ecosystem service. It really means that even the urbanization break the nature hydrological cycle, but we still can use the open space in the cities to reverse that trend by providing ecosystem services. And in that space, there's a lot we can do in terms of the landscape architecture and urban planning, and to embed those functions into the city space. And the third one is the city comprising water sensitive communities. So we're really taking a social technical approach to this issue in a holistic way. So just give you another 4 operating principles that if you want to implement water sensitive cities. And the first one is, of course, to integrate various sources of water. And the second is we actually need to operate a combination of centralized and decentralized systems. And the third, of course, is to deliver this wide range of services to the community. The ecosystem surveys, urban heat, and everything I talk about today. And then lastly is really I want to emphasize that this is not just about a piece of engineering infrastructure or engineering technologies. They actually need to be integrated into urban design. So landscape architecture has a huge role and very important role to play in realizing the visions I talk about for the water sensitive city. Okay, that's it from me. Thank you very much. And I hope you enjoyed the presentation, and I wish you a great webinar today. So I look forward to maybe further the conversation in the near future. Bye now. Koda Hafez. Thank you.